that if you have questions or anything along the way, you're going to have to say something, because I can't actually see the chat.
No problem.
I can't see
questions to the
I
end.
can't see you, so I hope you can bear with me. So I'm going to try to put it back into presentation mode, and I will present. Right. So you see it in presentation mode now.
Yes, this is perfect.
All right. Thank you so much. So thank you so much for the invitation. I think this is a fantastic meeting. It's great to be able to have CERN be present. And I will just give a really quick introduction to CERN. Many of you will know CERN, maybe some a little bit less. So this is really just a very broad overview. And then I'll dig a little bit deeper in terms of our programs when it comes to education and training, which may be of particular interest to the students looking for opportunities to engage with CERN or other laboratories. So this is just a quick introduction in terms of what CERN is. So CERN is the world's biggest laboratory for particle physics. You see here a very nice outline. I don't know if you see my cursor, but you can see here an outline of our flagship particle accelerator, the Large Hadron Collider, which straddles the border between Switzerland and France. You see the nice red border here, Switzerland here, France there. And our goal is to understand the most fundamental particles and the laws of the universe. There are 4 pillars to our mission. First and foremost, of course, fundamental research in particle physics. All of this is carried forward by a very extensive international collaboration. And this is, of course, where we're looking also to work with more students and academics from Afghanistan. And in order to answer the big questions in particle physics, we need to innovate. So fundamental research is a driver of technology development and innovation. And all of this together provides an extremely rich training ground for the next generation of physicists, engineers, IT professionals, and many others. And I'll just say a couple of words about each of those pillars in turn. And I think maybe the most interesting will be the focus on education and training opportunities. So fundamental research, you see here a very nice photo. This will be particularly well known to Kate, which is a very nice photo of the Atlas detector when it was constructed in the 2000s. And you can see a colleague here. So you see the size of these particle detectors. We try to answer what the universe is made of. This is one of the fundamental questions. So we study the elementary building blocks of matter and the forces that control their behavior. And this is, of course, interesting in its own right, but it's also interesting to understand how the universe has evolved, developed over time. This is a nice representation of the development of the universe from the Big Bang and until today. And of course, there are, there's very well complementary methods to study the universe. One is telescopes, and because the speed of light is finite, the further we look back into the night sky with our telescopes, either ground-based or space-based, the further we look, the further we look back, the further we also look back in time. But there is a challenge with this methodology, because in the beginning, the universe was so hot and so dense that light could not propagate. So no light comes to us from that era that we can see with our telescope. So we need complementary methods. And this is where the particle accelerators that are the tools of the trade here at CERN come into play, because with those we reproduce the conditions a fraction of a second after the Big Bang, so that we can understand how the universe has evolved over time. So to answer these big questions, we developed technologies in 3 areas. Particle accelerators, this is the Large Hadron Collider and the accelerator complex here at CERN. Particle detectors, that effectively are our cameras, our eyes to understand what happens in the accelerators. And then, large-scale computing to store and to analyze the data that comes out of the detectors. So just a couple of words about these tools in turn. The Large Hadron Collider, I showed you the outline at the beginning, is the world's largest scientific instrument, 27 kilometers in circumference, about 100 meters underground here in the countryside, where superconducting magnets steer the particles around their trajectory around the ring, and they're accelerated to close to the speed of light. And then they're brought into collision at 4 points around the ring in giant detectors, the Atlas and CMS detectors. You see here, those are what's called the all-purpose detectors. They look at all types of physics phenomena coming out of the collisions. And ALICE and LHCb that are a little bit smaller, but not by much. And they look at more specialized physics phenomena. The Large Hadron Collider produces more than 1 billion particle collisions a second, and the energy of the particles are then converted into new particles, and the detectors then measure the energy, the charge, the direction of the new particles. And effectively, the detectors are large 3D cameras. They take 40 million pictures a second, and about 1,000 of those are selected and recorded. And this is why we need very sophisticated computing. And this happens in what's called the Worldwide LHC Computing Grid, which is a global networked computing infrastructure where the data coming out of the Large Hadron Collider and the accelerator complex here is stored, distributed, processed, and analyzed. And there are data centers in more than 40 countries, over 170 in total, and over 1,500 petabytes of data stored worldwide. So I think it's the largest repository of scientific data in the world. Now, all of this happens in a very extensive international collaboration. CERN was founded over 70 years ago, initially with 12 European member states. Now we have 25 of them. We have 10 associate member states. And then you see we have cooperation agreements with many, many countries around the world. And this is what we together call the CERN community, about 17,000 people from across the world, physicists, engineers, IT professionals, and many others who come together in order to work at or with CERN, because not everybody is actually here at CERN. Many are working in universities, institutes across the world, and then contributing to the science from there. Fundamental research is a driver of innovation, so many of the technologies that have been developed here at CERN have found application in society in many different fields. The World Wide Web is probably the most well-known example, but it's certainly not the only one. Many technologies, both accelerator technologies and detector technologies, find use in the medical field, in material science, and many, many other areas of societal life. Now, I want to spend a little bit more time on education and training, because this is a core mission for us, not just, of course, to train and educate and engage the next generation of particle physicists who will be working maybe with CERN, within the CERN community, but also in many other areas where we train and educate young people to take up different roles in society. At any one point in time, we have about 5,500 young people in different types of education and training programs at CERN. And you see some of them here. We have a very extensive graduate program. I want to highlight here the 3,000 PhD students that are working with CERN at any given point in time. They are not employed by CERN. They're employed by universities, institutes across the world, but they come to CERN or they work remotely on the science at CERN. Then we have a very vibrant summer student program for undergraduate students and early master's students, and I'll speak a little bit more about that. And a very extensive program for high school teachers, where we also have an international programs over summer, where we have high school teachers coming from across the world so they can take home new types of teaching in particle physics, and also, of course, build networks amongst each other, which is helpful going forward. And we have an extremely interesting global competition for high school students, where high school students can propose an experiment to be undertaken here at CERN or one of our partner laboratories. And we've had more than 20,000 students take part in this over the past 10 years. So if we look a little bit more at the education and training opportunities that might be of interest to some of you, I want to just flag some here. I spoke about the summer student program, and there we have part of the summer student program is reserved also for students from outside of the CERN member states. We have had students from Afghanistan participating in this program, and we hope there can be more for the future. So this is bachelor and early masters students. Then we have also a very new program, for a doctoral student program for non-member state students, so students that are not part of the member states of CERN. This is funded through philanthropy. We have a foundation, and we have the first students that have come here to spend some of their time doing a doctoral dissertation. Again, they are affiliated to an institute or a university outside of CERN, but they will be spending some of their time here at CERN. And then obviously Beamline for Schools, which is a very nice opportunity, particularly for high school students. It's very inspiring for young students to be able to design, propose an experiment that they might be able to come and undertake here at CERN. We've also had one team from Afghanistan. We hope there will be more in the future. And then the teacher program, where, as I mentioned, we have a very nice international component of that. And I think there's also opportunities there for teachers from Afghanistan to come and take part. Again, teachers are a fantastic multiplier. They bring home new ways of teaching and can really engage students in the physics and of course in many other areas as well. So I'm just flagging here the websites for the different programs. Maybe they can be helpful. The slides will be shared. They will be uploaded on the page so that you have all of this information. And of course, all of us here at CERN are also available to provide more information if you need that. So there's a lot left to do. Just to flag, you know this already, we actually really only understand 5% of the energy and mass of the universe. So there's a lot still left to learn. The Higgs boson itself is an incredible potential discovery tool for the future. There's so much we still don't know about the Higgs boson as a fundamental particle. Kate will be better placed to speak more about that. Matter and antimatter, why is there this asymmetry, which is good for us, but why is it there? What happened in those early moments of the universe to create this asymmetry? And something as fundamental as gravity, which is the force that most of us feel most connected with because we see it most directly on a daily basis. Why is that so weak compared to the other forces? There's really a lot still to understand, and we hope that you, some of you, all of you, will be inspired to be part of this journey going forward so that we can answer even better than today some of those outstanding questions. So I will stop there, Kate, and open for questions and comments, etc. I will see if I can find you again.
Thank you, Charlotte. That was
There you are.
Really wonderful talk, really motivational. And it's so nice to see all the different work CERN is doing and all these really nice educational programs in particular. Yeah, Baktash is can't talk today, but he's sent a really nice message. He said that we had an amazing vision of establishing a research group in Kabul University, collaborating with the Atlas experiment. This was during the Sahepi workshop in Kathmandu in 2017. And this is when we initiated Physics for Frontiers Afghanistan. And since then, there's been much progress, of course, with many students going on to masters and PhDs. So hopefully, we hope that in years to come, that collaboration with Kabul and with CERN will manifest. So do we have more questions, comments? Let me open up, see if I can work out. From the participants, I know you must be tired. You've been here for a long time. But any other comments or questions? I was going to ask actually about the new program that you have. So this is this is really nice. It's a PhD opportunity for students doing their PhDs. Is this right? Abroad, not at CERN, but being able to come for, is that a year or so?
Yes, up to, usually it starts with 12 months. And we realized that there was a gap. We had a very nice and very successful summer student program, which gives opportunities for bachelor's and master's students. But then there was a little bit of a gap for those coming from outside of the circle of member states at CERN. And this is why, with the support of the CERN Society Foundation, which is a non-profit organization that helps, association that helps us to collect funds for some of the activities that we can't fund with a regular budget of CERN. We've introduced this program so that we have opportunities also for those, not necessarily those who only those who've gone through the summer student program, but in order to close that gap, so we have opportunities also for non-member states students at high school level, also for the teachers, so that allows to nourish already at that stage. And then we have, through the summer student program, opportunities at bachelor's and master's level. And then hopefully with the doctoral program, we can provide a bridge so that we can also help nurture. This is the basis also, you spoke about the group at Kabul University of Baktash. This is also an opportunity then to create the basis for some that may wish to go on to establish groups and to then continue to work with CERN. So there was a missing piece of the puzzle, if you will. And currently we have 5 students in this program, and we're really hoping to expand that also as we go forward. So it creates, together with the other programs, sort of a continuum that will allow us hopefully also to build capacity and encourage groups to form in universities and maybe in countries that have not yet worked so much with CERN.
Yeah, no, that's really fantastic, and it's a really great coverage. We will share with all the students here about the summer school programs, the Beamline to schools to advertise to local high schools, and all the nice CERN opportunities. Okay, Zainab, you have your hand up.
Thank you very much, Charlotte, for this presentation. I wanted to ask you, particularly in the situation that for many students is somehow very difficult to be able to access some education because there are a condition for traveling, visa, and especially for Afghan students, it's a very serious issue, particularly these days. Is there any way or possibility that students can still benefit by participating in some online programs or something that they can benefit even if they are not able to present themselves? And
yes, you know what, that's a very good point. And now in hindsight, I should have included that also in the slides, because we do actually have online opportunities. Also, we have a new, effectively a MOOC that's been created, a particle physics course online that has been created sort of more tailored towards high school students, but I think also very interesting at different levels. So maybe I'll add that to the slides. We also have, I think maybe Kate also will know about these master classes through the what's called the International Particle Physics Outreach Group, IPOG. That's another strand. And that happens, I know Kate has been working very much with this also in the past, so that's more happening in country rather than at CERN. And then we also have the opportunity through the experiments to do online visits. That has also been something that has been very useful for those who may not be able to travel. So there are opportunities to be engaged with CERN through different online resources. So maybe I will just add that to the slide so that you also have those opportunities that you can see. So absolutely, yes, that's also a possibility.
Wonderful. Thank you very much. That would be really great help for students. Thank you.
Thank you. And thank you so much, Charlotte, for joining and for preparing the presentation. We will share with all the students.
That's great. So maybe just wait, Kate, until I have added the other links.
Of course, let's do that. Perfect. Thank you. Okay, so let's close the morning session. I hope you've really enjoyed all the different talks. We should thank all of our speakers for contributing today. And we look forward to the second session. So we will start in 30 minutes, where we'll have the talks from some of our wonderful students here to talk about their research, which we very much look forward to. Thank you. Thank you to Charlotte, and thank you to all of our speakers.
Have a great day.
Thank you.
Bye.
Thank you. See you. Bye. So we will see you all in 30 minutes. Please go and have a rest, have some food or a tea, and we will see you in 30 minutes to start the next session.